this video I will be explaining some special types of matrices. The first type of matrix that we found is row matrix. As its name indicates, a row matrix is one that has only one row. For example, this one, let's call it matrix C. It has only one row. In this case, we have 3 columns, 1 row. The size of the matrix is 1 by 3. So the first number in the size of the matrix will be 1. And usually people call it a row vector. There will be also column matrix, and a column matrix has only one column. And as an example, we have this. We have only one column. If we say the size of this matrix, the second number of the size will be always 1. For example, in this case, the matrix H is of size 4 by 1. And again, a column matrix is also called a column vector. When the matrix has only one row or one column, we call it just a vector. So these are the first type of matrices. There will be other matrices that are called square matrices, and this is the cases when the matrix has the same number of rows and columns. Square matrices are always n by n matrices, so if we say the size of the matrix, the two numbers will be the same. An example will be something like this. So in this case, matrix B is a 3 by 3 matrix. So obviously a 4 by 4 matrix will be also a square matrix. A 5 by 5 matrix will be also a square matrix. This matrix, for example, when we have only just one number, this will be a square matrix. This is a 1 by 1 matrix. There will be also some matrices that are called zero matrix. A zero matrix will be, as the name indicates, a matrix when all the elements are 0. There is a zero matrix of any size. For example, there will be a zero matrix of 1 by 3, or a zero matrix of 4 by 1, or a zero matrix of 3 by 3. So for each side will be a zero matrix. And as an example, we have this one. This will be a 3 by 4 zero matrix. Other type of matrix are the upper triangular matrix. An upper triangular matrix will be a square matrix in which all the entries below the diagonal are 0. So we can say this in symbols. We say that if Aij is the element of an upper triangular matrix, if I is greater than j, implies that A sub ij will be 0. For each entry in which the number of rows is bigger than the number of columns in the location, in the position of the entry, this element will be 0. For example, this matrix here, we notice that, for example, in this number here, the number of rows is 2 and the number of columns is 1. 2 is greater than 1, so in this case the value is 0. Or for example, this entry here, when the number of rows is 3 and the number of columns is 2, 3 greater than 2, so the element will be 0. Anytime that we have an entry in which the number of rows is bigger than the number of columns, this entry will be 0. Obviously, an easier way to explain will be saying that every entry below the main diagonal, and we call it this a main diagonal, all the elements in which the number of rows is equal to the number of the column, so every element below the main diagonal is 0 in an upper triangular matrix. This is another example. This is an upper triangular matrix of size 3 by 3. Observe that the number above the diagonal could be 0. Why not? The only requisite is that below the diagonal, all the elements need to be 0. You don't care about the other elements. This is an example of a matrix that is a 3 by 3 matrix that is an upper triangular matrix. Or this matrix, for example, this is a 2 by 2 upper triangular matrix. All of them are upper triangular matrix. And of course, if there are upper triangular matrix, will be also lower triangular matrices. So a lower triangular matrix, the definition is the opposite of this. It is a square matrix in which all the entries above the diagonal are 0. So, so if we say this in symbol, will be all a matrix in which all the elements A sub ij satisfies this condition. If I is less than j, if the number of the row of this entry is less than the number corresponding to the column, that implies that the elements will be 0. For example, this will be a lower triangular matrix. Look at that, this number, when the number of row is 1, is in the first row, but it's in the second column. So 1 is lower than 2. So the number corresponding to the row is lower than to the number of the column. This entry needs to be 0. And whatever entry in which the number of the row is lower than the number of the column, this entry will be 0. A better explanation for human beings will be saying that every element above the main diagonal is 0. This is an example of a lower triangular matrix, a 4x4 lower triangular matrix. This is another example. This is an example of a 3x3 lower triangular matrix. And here we have an example of a 2x2 lower triangular matrix. A triangular matrix is one that is either lower or upper triangular matrix. If somebody tell you we have here a triangular matrix, so this triangular matrix could be an upper triangular matrix or a lower triangular matrix. And there are diagonal matrices. In these matrices, only the elements that cannot be 0 will be the elements in the main diagonal. A diagonal matrix will be a square matrix in which every element outside of the diagonal is 0. A diagonal matrix is both lower and upper triangular matrix. So we can say in symbols that every element A sub ij will be equal to 0 if I is different than j. Because we know if I equal j, then the elements is in the main diagonal. If I is different than j, if the number of row is different to the number of column, then this entry will be 0. For example, this will be a diagonal matrix. The only element that could be not 0 will be the elements in the main diagonal. This is an example. Here we have a 3x3 diagonal matrix, and here we have a 2x2 diagonal matrix. Obviously, the elements in the diagonal could be 0. Yes, we don't say anything about them. The only requisite is that the elements outside of the diagonal need to be 0. The elements inside of the main diagonal could be or not be. A square 0 matrix will be a diagonal matrix, of course, because the elements outside of the main diagonal are 0. And there is something that is called an identity matrix. An identity matrix will be a matrix that is a diagonal matrix, so it will be a square matrix, and the element outside of the diagonals are 0, but they have the additional condition that every element in the main diagonal needs to be 1. So an identity matrix of side n, denoted usually I sub n, is a diagonal matrix having only ones in the main diagonal. So the fact that they are diagonal matrix so means that they are square matrix. And we're gonna say n, only one number for the size, because this is a square matrix. We don't need to say two numbers. The number of columns and the number of rows will be the same. So we can say just one number for the size, and that will be the number of rows, or the number of columns that will be the same. So for example, I sub 1 identity matrix of size 1 will be number 1. And this will be the identity matrix of size 2. So we have, there is only one identity matrix of size 2 because they have two conditions. They need to be diagonal matrix and also need to have, for sure, all the elements in the main diagonal to be number 1. So there is only one identity matrix of size 2. We are going to call it I sub 2. The identity matrix of size 3 will be this one. There will be only one identity matrix of size 3. And again, one identity matrix, only one identity matrix of size 4, etc. So it will be just one identity matrix for each number. For example, there is one identity matrix of size 20. So it will be I sub 20. That obviously I'm not going to type here. Okay, this is the most important type of matrices, but there will be some others that will appear in this course. But so far we have for today this type of matrices. Thank you. In the next video I will be showing you some operations of matrices.